8.3a. Let's start with some review. What is the shortcut to see if two triangles are similar? Well, it is AA. Remember our angle shortcut? If the scale factor between two similar polygons is 2 to 3, then what is the ratio of their areas? Remember, the ratio in terms of areas are the squares. So it's 2, 3 squared squared. So 2 squared is 4, 3 squared is 9. So our ratio is 4 to 9, or we can say 4 dot dot 9. Next one, another shortcut that we can use with triangles are SSS. You could remember that from our congruent triangles, side, side, side. But here we only need to prove similarity. So we only need two sides. So our side similarity theorem, if the corresponding side lengths of two triangles are proportional, then the triangles are similar. So let's check here if PQ is over ST is equal to PR over SU is equal to QR. So our corresponding sides is over to TU. So our corresponding sides, the ratios all being the same, they should be similar. So let's see here. PQ is 8 over 4, PQST, so 8 over 4. If I simplified that by dividing both of them by 4, this gives me what, 2 over 1. PR is 12 over 6. If I divide both by 6, this gives me 2 over 1. And then just for last measure, QR and TU, this is 10 over 5. If I divide both by 5, I get 2 over 1. I get 2 over 1, 2 over 1, 2 over 1. All the sides are proportional. Then definitely we can say triangle PQR is similar to triangle STU. Okay, let's try this out. Decide if the triangles are similar using side, side, side. If so, show the sides are proportional and write a similarity statement. So let's check here. We have 12 over 8. For the first ones, 12 and 8. Those are the matching corresponding sides. Divide both by, say, 4. That's the same as saying 3 over 2. So we got a 3 over 2. Let's do 18 and 12. So 18 over 12, divide both by, say, 6. This is 3 over 2. So far I got 3, 2, and 3, 2. Let's do the last one, 15 and 10. So 15 and 10 divide by 5. This gives me 3 and 2. So I got 3, 2, 3, 2, 3, 2. They are similar because of all the sides. So we just proved that 3, 2 is equal to 3, 2, which is equal to 3, 2. My similarity statement, triangle ABC is similar to triangle DFE. Remember, got to match the angles together. So D pairs corresponds with A, so D goes first, so DFE. Number 2, let's check to see if they are similar. Let's do the bottom first. I see 5 over 9. Well, that's just 5, 9. I can't reduce that. and a 12 over 12. 12 over 12, that reduces, if I divide both by 12, that reduces to 1 over 1. 5 over 9 and 1 over 1 are not the same, so they are not similar. So we can say 5/9 does not equal 1 over 1. Let's look at number 3. Number 3, I got 4, 4, and a 5, 5, 5, and a 6. Let's check my 5 and my 6 first. Well, let's see here. 5 over 6, that cannot be reduced. And then 4 over 5. The other one is 4 over 5. Those are not the same. I can't reduce either of them. So these are not similar because 5 over 6 is not equal to 4 over 5. And I don't have a similarity statement because these are not similar. Let's keep going. Try it out. Use side, side, side. Are these triangles similar? If so, write a similarity statement and state the scale factor. Okay, number 4 is either triangle DEF or GHJ similar to triangle ABC. Well, they all kind of look similar. Let's check. First one, ABC to EDF. So the first one and the middle one. This side, if you notice, pairs with this side because those are the shortest ones. So I'm going to check that first. So 6 over 4, divide both by 2 to reduce. So this gives me 3 over 2. Let's do the next one, 9 and 6. So 9 over 6, divide both by 3. This gives me 3 over 2. So far, so good. And then my last one, 12 and 8. 12 over 8, divide both by 4. This gives me 3 over 2. So these are similar because 3 over 2 is the same as 3 over 2, which is the same as 3 over 2. Let's check with find GHJ. So the last one. Here I'm going to erase this part a little bit. I want to match this side with this side. So 6 over 6 is a 1 over 1, okay? Let's try my 9. Oh, and my 10. 9 and 10 can't reduce that, but they are not equal because 1 over 1 does not equal 9 over 10. So these are not similar. Finally, let's go to number 5. Is either triangles similar to each other? So let's check LMN to RST, which is the left and the middle one. So let's start with, this looks a little bit tricky because this triangle looks like this triangle but rotated. So if I had to pair up, I think angle L matches with angle S. So my first numbers, I am going to work with, because the smallest one is 20, I'm going to do 20 and 24. So 20 on top, 24 on the bottom. I can divide both by 4. This gives me 5 over 6. Next one is going to be 26 and 33. So 26 over 33, if I divide both by 26, 33 is 3 times 11, and 26 is 2 times 13. So I can't reduce those anymore. 26 and 33 cannot be reduced. So it is just that, 26 over 33, because 2 times 13 and 3 times 11, there are no factors are the same. So we can say 5 over 6 is not the same as 26 over 33. So these are not similar. Let's check the last one. LMN, so the outside angles. So this is, we're going to check the outside angles to see if they are the same. Not the same, but similar. Let's start with 20, the smallest number, with 30. So 20 over 30, if I simplify that to get rid of those zeros, I get 2 over 3. Okay, so far so good. Next one, I do 26, which is the large number. 39 is the largest number. So 26 over 39. 39 is divisible by 3. It's 13 times 3, and the top one is 13 times 2, so I can divide both by 13. This reduces this to 2 and 3, so far so good. And then the very last one, I can check just for safe measure, 26 and 36, 20, not 26, but 24 and 36. That's 24 over 36. Divide both by 12. That's 2 and 3, and they're all the same, so they are similar.